For our next example, once again, it's an equation. I'm being told to solve. I want to find out what works for x. If we're not comfortable with logarithms, if that's something that is harder for us to solve, let's just bounce it straight into exponential form. Base of x, the logarithm is my exponent, equals 16. Now, when we're asked what equals 16, what's squared? 4 is one of our more apparent ones. 4 squared is 16, true. But also, negative 4. If I have negative 4 times negative 4, it's going to give me a positive 16 also. X is going to equal, and this is one in Math Excel, separate your answers with commas. 4 and negative 4 are what work for x right now. The problem is, 4 and negative 4 don't work for x up here. Remember our restrictions. When we talked yesterday about a times b to the power of x, that b had two restrictions. Remember, b could not be 1, b could not be 0, and b could not be negative. Now, don't let that be that your x can't be. It just happens to be that since your x is your base, that's what can't be negative, 0, or 1. Or it can't give you anything that gives you a 0, 1, or a negative base. Let's look at some hypotheticals. In this case, what I would say is, I can't have a negative 4 base. I call that, if you remember the term, extraneous solution. But when I said that was extraneous, remember, extraneous does not mean no solution. My solution is still 4. And sometimes one will work, sometimes both will work, sometimes neither will work. You never know. Even back here, this one answer could have been extraneous. If that were extraneous, I would have said no solution. If both were extraneous, I would have said no solution. You never know. You just let the problem play out. Now, again, just because it's negative, let's look at those hypotheticals. If I had had log base x plus 5 of 16 equals, and then I don't care what's on that other side. If I have log base x plus 5, if I were to plug in negative 4 now, notice it's not the negative x that's the problem, it's what gives me a negative base. If I plug in a negative 4, I get negative 4 plus 5 is 1. It's no longer bad because it's negative. But the problem is, it can't be 1 either. So what I'd say is, then it would still be extraneous, but let's think of another hypothetical. What if it had an x plus 6? If it were x plus 6, well, now I plug in that negative 4. It's not the negative that's the problem. It's as long as it's not a negative base. That would be a plus 2. It's totally fine to have a base of 2. I had a base 2 back here. Even now, since it's not that 0 and 1, that would have been a solution. I would have had both answers work had that been an x plus 6. Now again, another hypothetical. What if you have log base x minus 6 of 16 equals some of the number? And these are the two answers you got. If I plug in that negative 4 now, negative 4 minus 6, that's a negative 10. I can't have a negative base. Negative 4 would have been extraneous. Just because it's positive doesn't automatically make it good, because what if I plug that 4 in? The 4, even being a positive 4, 4 minus 6 is negative 2. It's the x's that give me a negative base that I've got to be able to trash as extraneous. Even right now, in this problem, 4 would have been extraneous too. That would have told us no solution because both of the numbers. Those are some hypotheticals, but just keep all that in mind as far as interpreting, is my answer acceptable or not?